All right. So generalizing equations. All right, so this is just showing you like how to determine what type of an equation it is. So whenever you have a combustion reaction, and combustion reaction should kind of seem like something's maybe having like a little bit of an explosion, and that is what it is. Like, whenever you're producing any kind of combustion reaction, you're having a little bit of a kind of an explosion. Not in like a huge sense. Like there's a combustion reaction that happens inside your car. That's how it can start. There's a little sparker, and it will ignite, and that's why you have your gas, and nothing explodes. Obviously, like your car doesn't explode, but there is a small little combustion reaction that's happening inside that. Okay, so whenever you have any kind of combustion reaction, you are yielding carbon dioxide. So remember how to name carbon dioxide. And this is technically dihydrogen monoxide, but I'm just going to call it water. So whenever you have a combustion reaction, you let off carbon dioxide and water. Okay? And it's when some kind of carbon hydrogen is mixing with an oxygen. Okay? Oxygen is never going to be by itself. There's always going to be at least two oxygens, that are attached together as a covalent bond. So this is showing you the four alternative classifications. And it's they look a little scary, but it's really not too bad. So the first one is the combination reaction. And so I always think of this one like, I don't know, guy meets girl, and then, they get married or they're together. Whatever you want to think there. Okay? And this is where two elements they synthesize together, okay? They combine together. The next one is known as the decomposition reaction. So they were together, and then now they are apart. So, got in a fight or something. Who knows? This next one is the replacement reaction. This is what I call the home wrecker. So you've got the negative part or the positive part. So just remember that whenever you have a compound, typically the metal, right, was always in the front, and then the non-metal was in the back. So this is saying that the negative part, so that would be the non-metal, is being replaced. So you've got X and Y are together, and then Z's over here by theirself, and then Z comes in and kicks Y out. That's why I call it the home wrecker. And now Y is off by itself. So that's the non-metal, because the non-metal was on the second part, right? It's in the back part of the compound. And then you've got the positive part being replaced, or the metal. So again, home wrecker, but now the positive part is replacing that X, and now X is off by itself. All right? And then a redox reaction, so this is wherever you are getting either something is helping to reduce the situation, or they're helping, which means that they're adding more of a negative component to it. Or an oxidation is where they're actually like adding more like a positive to it. So we'll get more into that in a minute. And then you've got the ion exchange. So now, what happens in this one is that they're just exchanging. And I thought that there was a formula for that one. Let me just make one up. So it would be like AB plus CD yields AD plus CB. Now, why did I do AD instead of AC? So this is the metal. Right here's the metal. This is the non-metal. They're going to replace. So this is a metal. and a non-metal. So the metal has to go with the other non-metal. Okay? So AD and C with the B now. Okay? The metal has to go first. And it can only go with the other non-metal. Here's the oxidation reduction. So an oxidation here is a loss of electrons. So if you're losing electrons, then you are more positive, right? If you're a reduction reaction, then you're gaining electrons. So that's a gain of electrons. So here it's showing that the iron in the ore, you've got iron oxide here plus some carbon. And now you've got iron off by itself and carbon and oxygen are together. So iron here got kicked off by itself, and carbon sort of was the home wrecker in this situation, because carbon was out by itself, and then after the reaction, now it kicked iron out of the way. So iron gained electrons, okay, from the carbon. So the reducing agent is going to be then that carbon, okay? All right, so this is showing you just another example of a combination reaction. So this was our general equation. So if you have like iron and oxygen and you add those together, then they make iron oxide, okay? And I just want to show you here really quick too. Let's just do a quick little a balance, because I just don't think that we're getting enough practice of that yet, and I just want you guys to understand how to balance equations. So what you do is you write your reactants and your products. Now, what reactants do we have over here? We have 4 irons, and we have, how do you figure up how many oxygens you have here? You have 3 times 2, so 6 oxygens. And then over here, you have 4 irons, because you have 2 times 2, and then you have 2 times 3 oxygens, so 6 oxygens. Okay, so it's balanced. Now, see these coefficients? Those are not going to be there whenever you have to balance equations in the homework. So, or the lab. The lab's going to be about this as well. So that's the part that you have to figure out, is the coefficient part. Okay, and it just kind of takes practice. All right, a decomposition. So here you've got, your X, Y, and then it breaks up into the separate. So here we've got mercury oxide, and here it breaks off into mercury and oxygen. Okay, and I just want to point out again, see how this 2 is multiplied to just the mercury, and then over here to the oxygen. All right, so there has to be 2 on the product side. A replacement reaction. So here you've got, it says an atom or a polyatomic ion. So like the table 9.3 is replaced in a compound by a different atom. So this is just showing you, like, if you took aluminum and this blue solution of copper, and you put the aluminum, it says that the aluminum is above the copper in the activity series, which is a table inside your book, and it's not going to give it to you on this PowerPoint. But since it is above it, the aluminum replaces the copper ions from the solution as copper is deposited as a metal. So the aluminum loses electrons to the copper and then forms aluminum ions in the solution. So this aluminum kind of breaks up into this, and you can kind of see that the copper attaches itself to this a little bit, on this aluminum here. So it's replaced. And then you've got this ion exchange reaction, which is where, like I said before, they just exchange ions. And so like, for instance, this one then exchanges with that one and becomes AY. and then B is the metal, and so it ends up, combining with the X over here. Okay? And this is just saying that it interacts with ions of another compound, and so you can end up with a solid, a gas, or some kind of water. Okay, I think I'm going to stop here and start a new one because I'm just not sure how much time I have left.